Welcome to Structured Dynamics' Open Semantic Framework Academy. This is tutorial number 1, Introduction to the Open Semantic Framework, or OSF. And I will be your host and presenter today. I'm Mike Berkman. What we'll be covering today in this introductory session is what we call the 5 W's and the 1 H. Basically the why, what, where, how, and as well welcome you to this, our kickoff session in the Academy. The Open Semantic Framework is proud of the amount of documentation that it already provides online, with more than 500 technical documents located on our wiki. But the Academy kicks off for us a series of anticipated multiple dozens of screencasts dealing with all aspects of how to install, configure, set up, manage, and use an OSF or Open Semantic Framework installation. As a result, we're going to be covering a lot of the high ground in today's presentation, some of which we will not go into detail on the slides, because in later sessions we will delve into many of these topics with real online demos and interacting with an OSF installation in subsequent screencasts. So let's first discuss why the Open Semantic Framework was created in the first. Our commitment is to provide a platform that is focused on questions of data integration and interoperability for enterprises. We wanted this system to be open source in keeping with today's trends, and to have all the capabilities that enterprises expect in an enterprise scale platform. Importantly, we wanted to be able to integrate and include unstructured data, that is text, which represents about 80% of the knowledge content within enterprises, as well as semi-structured information like web pages, XML files and such, as well as traditional database-related information and spreadsheet information, which is known as structured data. All of this is geared toward providing answers and assistance to knowledge managers within the enterprise. In keeping with our semantic orientation of the platform, we have adopted what we've called an ontology-driven approach. This is not only in terms of how you model the enterprise's domain or its area of concerns, but also how the platform itself operates internally. And thus we've created a platform that has a set of generic capabilities with individual installations able to modify and tailor it for specific enterprise needs based on swapping out the particular ontologies that are used to drive the system. We can look at this in figure form by saying that the Open Semantic Framework is a generic capability that, by virtue of how you want to present information with different visualization widgets, as well as how you want to model and capture your particular domain space, you may have installations that range all the way from semantic government applications to financials, enterprise, and so forth, merely by changing the schema directions that are provided to the OSF framework. And so what is the OSF? Well, it is an integrated single platform based on multiple components, both those from the outside world, open source, as well as many connecting parts and glue that my firm, Structured Dynamics, has provided in order to provide a complete turnkey platform. The system is based on W3C standards in areas like Resource Description Framework, RDF, the Web Ontology Language, OWL, and many other W3C standards. Because of that, and because of its semantic orientation, it follows what is known as the open world assumption, which we will touch on briefly here, but expand on in later sessions. And also in keeping with its application to web-oriented applications, we follow what is known as a distributed web-oriented WOA architecture. The importance of using a single canonical data model, that is RDF, at the center of the system is that the system itself, as shown here by the OSF bubble, is all based around basically the RDF data model, so that we have a single set of tools that are operating on all of the information ingested into the system. With a series of various converters and so forth, however, we can turn any wild in the native data source from unstructured to structured into this RDF form, which is then used for bringing in and OSF doing its work. Similarly, if you want to use external tools with the information contained within an OSF platform, through various export mechanisms, we can reconvert that RDF internal data back into native forms for use by third-party applications and other existing applications with the enterprise. And this can be things like JSON, XML, etc. There are many advantages of a canonical form, canonical model at the core of a system, mostly being the one that we can create this generic capability that as you feed it different schema or ontologies, you're able then to drive a finite set of capabilities and widgets, all of which are working off of the same form. So by virtue of, if you will, providing a highest common denominator in terms of a very robust data model, we are able to build a suite of tools, generic capabilities working from that can be applicable to virtually any enterprise application. As I noted earlier, ontologies within the Open Semantic Framework really play two different kinds of roles. One role is to describe your enterprise, your domain, and that's basically the knowledge schema, the relationships of concepts and terminologies within your particular field of endeavor. These are known as domain ontologies. Secondly, there are ontologies that are used to actually inform and drive the OSF system itself. These are administrative ontologies, and they govern such things as what kind of widgets to present when particular data is returned from a search, how to go ahead and modify and manage and control the application. These tend to be in the background and ones that you will not directly modify, but are part of the complete suite of ontologies that basically set the whole ontology-driven nature of the OSF. Also, as I noted earlier, this set of technologies, and particularly the standards from the World Wide Web Consortium, W3C, basically puts forward an approach of modeling and capturing the information in the world that's known as the Open World Assumption, or OWA. In essence, the Open World Assumption says we only know what the system has been told. We are open to receiving new information and incorporating new information. And as we do so, we just need to make sure that that information does not contradict what's already stated. This is different than traditional databases, which have followed closed world approaches, which are very good for transaction systems and where things are very finite and well bounded, such as revenue models based on number of seats on a plane, things which are fixed and bounded in both in domain and information. Transaction systems are then able to assume that they're dealing with the entire world when they do their calculations, and that's very efficient for those purposes. But in knowledge-oriented applications, where we're always learning more, new facts are being generated, new learning is being created, we need to be able to add to our growing understanding of our world without having to re-architect what already exists in the system. And so the open world approach is very, very well suited for knowledge applications where we're continually learning, expanding, and modifying our understanding of the world we live in, and being able to do so in a way without having to re-architect our underlying data schema each time one of those new learnings or changes occur. So the open world is extremely well suited for knowledge management applications. Closed world in general, to make a simple sort of statement here, are very good for transaction type systems. We began the effort around the Open Semantic Framework shortly after the formation of Structured Dynamics back in 2009. And through the generous assistance of clients over the past 5 years, we have gone through many modifications and improvements and expansions. And today, in 2014, we are now in version actually 3.1 of OSF. So how do we make and create and set up this OSF platform? Well, firstly, we did not want to reinvent the wheel. So we have assembled best-of-class open source engines. These are the core of the OSF system that already exist out there. We'll elucidate them here in a second. And then provide a common way of accessing those different engines. We put on top of that a layer of RESTful web services. Today there are nearly 30 within the OSF pantheon. Part of what we did in those web services is to extend the standard semantic model with so-called CRUD capabilities, create, read, update, and delete, so that we also can make the systems not just static captures of domain information, but interactive data managers of domain information. And as I noted, we wanted to architect this to be consistent with modern web architecture, and then in keeping with our belief that the water does not stop at the shore of open source software, but also needs to include a full suite of installation and testing tools and documentation. We have rounded out our offering in those areas as well. At the simplest level, the architecture of OSF really can be seen as three broad layers. At the bottom, basically the data management side of things are the OSF engines. Layered above that, for access and uniform web-oriented protocols, we have our RESTful web services. And at the top layer is a content management system. In the most general case, we utilize Drupal, where we provide then through those systems a means of providing user interfaces, standards, and other third-party tools that can be integrated with the OSF system for a full-featured platform. Now, a subsequent session will go into considerable more detail around the architecture. Here's the big diagram, but let's just briefly look at these three major pieces. At the bottom layer is what we call the OSF engines. What that is a combines at present an RDF triple store and Virtuoso, a full-text search and faceting piece from Solar, the ability to manage ontologies and so forth, and do interesting slices and dices of them using the OWL API. And then in order to bring unstructured data into the system, the generalized architecture for text engineering GATE for use of tagging and natural language applications. Now, these latter two that I mentioned are written in Java. Since our systems up above are written in PHP, we also utilize the PHP Java bridge, which gives us the ability then to, if you will, provide a uniform API access protocol to these four engines. Now, the engines are then interacted with by virtue of data sets. These are basically self-consistent groupings of records that have potentially different access rights and other things. And so they become the unit of interaction with those engines. And then for efficiency purposes, there's also a caching layer at the engine layer. That information then comes up through the middleware, which is firstly a series of these web services that I mentioned, and they are in things like CRUD for records, CRUD, that is create, read, update, delete, for data sets, for ontologies, as well as specialized services such as search, the import-export converters, taggers, so-called Sparkle endpoints for directly interacting. There's also revisioning and authorization activities that take place. Now, in various ways, through our various installations, we've also worked with many third-party tools. These are shown in green. Things like harvesters or web crawlers, multimedia repositories, version control systems, and then also security services, which in some enterprises may want something a little bit further than what the standard security layer is within OSF. And then for developer purposes, there's also an API layer that enables you to go directly to these web services via API calls, as opposed to strictly with web service RESTful requests. Then on top of that, we have a series of modules and what we call connectors, which take the information from down below, convert it into formats and conventions recognized within Drupal 7, such that standard Drupal administrators and developers can interact with all of the machinery in OSF more or less transparently. In other words, they can use conventional Drupal mechanisms, conventional Drupal screens, conventional Drupal modules for working with not only Drupal itself, but for connecting and integrating and talking to the OSF layers underneath. Now, the way that the system works from an interface perspective is that users will go to a web page, they will make some choices. Those choices, filtering, selecting, will generate queries in the background, which will go down to the web services layer, which a request will be issued to the engines, results will come back. Those results will be matched then with some of these administrative ontologies and domain ontologies to create up a schema of results that are then presented back through a series of appropriate widgets that then the user can select which ones they want to display the information. And now the information is again shown in the web page, all of which is in a virtuous cycle of interaction. So where can we learn more about this? Next, I'm going to show you a few examples of where OSF is in place on the web that you can go play with. And here is the listing of those that we will go through in rough order. The first site I'd like to show to you is the PEG site. That's at mypeg.ca. And this is sponsored by the United Way of Winnipeg and the International Institute for Sustainable Development. And its purpose is to present and engage local publics in the Winnipeg area with indicators of well-being and sustainability for the community. Its information is contained within a number of indicators: education, economy, governance, health, and so on. And via this particular screen, you're able to navigate to particular topics and themes within those, as well as stories associated with them. You're able to see how these indicators affect the community in various ways. You can look at neighborhoods, for example, in terms of different types of data. And let's look at that via heat map. This highly interactive site is used to engage various social agencies and publics in the community to discuss how they are doing and to track progress for the community over time, all of which is driven in the background by the Open Semantic Framework. Somewhat related to that, we also have a neighborhood view of Winnipeg called the Neighborhoods of Winnipeg. This is sponsored by the City of Winnipeg as a way of publishing and putting forward open data sets, nearly 60 of them now, to their community. It has a neighborhood orientation, again, quite a bit of information regarding census and demographics, education, for example. You can pick various communities and areas. There are ways by which you can view community amenities and services and so forth throughout the community. So in a host of areas, economic development, parks, recreation, demographics, etc., there is nearly 1 million different data points within this system that's being managed and accessed by the community. A very different site was done for Health Direct Australia. Basically, this is a Australia-wide information portal on health topics, all of which driven in the background by the Open Semantic Framework. Various topics can be looked at. They generate contextual search with multiple search results panels that are presented based on the context as you look at various facets or aspects of that information. All of this is being pre-screened and presented through a series of tailored search templates, all occasioned by the faceted search capabilities within OSF. And then another quick example to show you is our own Citizen Dan sandbox. I'm showing this one because you can actually interact and play with the data, and it has a more complete coverage of various OSF features than some of the specific installations do. For example, this particular site, you can see and interact with the broad ontology that's at the core of this. This is the so-called Muni ontology that captures various aspects of how to model, in this case, a generic community or city, all of which you can inspect and so forth. So those are four examples, excuse me, of instances that exist out there that you can go look at. Now let's move on to see where we can get some additional information about OSF. Here are some of the follow-up main links. I'm going to leave this up on the screen for a bit, including the following screen, so that you might take down appropriate URLs to follow up with additional information. And of course, as we move forward, we welcome you to attend and listen to any of the growing series of other screencasts from the OSF Academy. And we're excited about being able to present these new capabilities to you via screencast. And we welcome to see you back again in subsequent sessions. Thanks a lot.